Good morning and welcome to lesson 26 of module 4. We are continuing with graphing systems of equations and finding solutions. Today we're going to focus on parallel lines and why they have no solution. As always, we are going to do some background examples, exercises. We're going to close out the lesson and then you'll do an exit ticket. And please make sure to keep in mind our expectations for this class. Alright, so today, like I said in the first slide, we are focused on parallel lines. And remember that when we're solving a system, which is two equations at once, the solution is wherever they overlap. And parallel lines are never going to overlap because they're continuing at the same rate forever. So when we find the slope of our lines, and the slopes are the same, but the y-intercept is different, that is when we get parallel lines. So same slope, different y-intercept. Okay? If this is the case, your lines are parallel and they're never going to touch, you're never going to have a solution. So that's what we're going to be working with today. Alright, starting off with example 1 here, I'm going to plot these two lines and then see where they overlap for the solution. So looking at my first line, y equals 2 over 3x plus 4. I'm going to go ahead and plot that. So I always want to start with my y-intercept. So where does it hit this y-axis? At positive 4. So I'm going to go up to positive 4 and put a point there because that is where it crosses. Okay? From there I'm going to look at my slope and figure out where do I go from that point. So it says the slope is 2 over 3. So this is our rise and this is our run. So we're going to go up 2 spaces. Okay, did up 2. And now we're going to go over 3 or right 3. 1, 2, 3. And so that is my second point. Okay, I could make another one here, up 2, over 3. Going to be another point right there. And then I talked to you guys about this yesterday, but we can work backwards and fill this space back here with points as well. And we're just going to walk backwards. So work backwards, sorry. Instead of going up 2, we're going to go down 2. So I'm going to go down 1, 2. And instead of going right 3, I'm going to go left 3 because I'm working backwards. 1, 2, 3. And so that's where that point would be. And then down 2, over 3. And so here we have our first line. I'm just going to connect the points and draw it out. Okay. Now I'm going to graph our second line here. It is y equals 4 over 6x minus 3. So remember to change this to a plus negative. So our y-intercept, where it starts off at this y-axis, is at negative 3. So I'm going down to the negative 3 and I'm placing my point. Okay? From there, I'm going to plot my slope, and it is 4 over 6. So we're going to be rising 4 and going right 6. So we're going to rise 4, 1, 2, 3, 4, right 6. 1, 2, 3, 4, 5, 6. Okay? And I think that's honestly all that we can plot here. However, I want you to look at this slope, 4 over 6. Does this reduce? Can it be simplified? It can. Both of those are divisible by 2. So if we cut both of those numbers in half, half of 4 is 2, half of 6 is 3. So let's see if this made a point in between. So 2 over 3. So up 1, 2, over 1, 2, 3. Up 1, 2, over 1, 2, 3. Yeah, this works out. Okay? It creates points on this graph as well. I'll do one from behind as well. 1, 2, 1, 2, 3. And the reason being is that our slope could be simplified. So looking at these two lines, they are completely parallel. And you can see that they're parallel now that I've simplified this because they have these same slopes. And they have different y-intercepts. They start at a different spot on our y-axis. So these lines are parallel. So, no solution to this system of equations. That is our answer here. And this is what we're just going to be practicing today. All right, for example 2, I'm not going to be graphing them. I'm just going to be writing these equations out And we're going to be talking about if they have a solution or not, and we're going to explain our answer. So this first system, this one is written in slope-intercept form, y equals mx plus b, but this one is not. So I'm going to quickly change it. So y plus 2 equals 5/4 x. I'm going to get the y by itself, so I'm just going to subtract 2 from both sides. And I get y equals 5/4 x minus 2. So if I look at the first equation they gave me, it was y equals 5/4 x minus 3. So let's look at our slopes. Well, slope of 5/4, slope of 5/4. So they have the same slope. And then let's look at our y-intercepts. Well, I have plus negative, so I have -3 plus negative, I have -2. They have different y-intercepts. And what does this mean? If they have the same slope and different y-intercepts, these lines are parallel. Which means no solution. All right. Moving on to number 2. This equation is already written in slope-intercept form. The second one is not. So I have 4x minus 8y equals 11. So I'm going to just do a few things here. I'm going to do keep, change, opposite. And now I'm going to subtract 4 x's from both sides. So I have negative 4x plus 11. And then I'm just going to divide both sides by 8. Kind of running out of room here, but divide both sides by -8. So y equals 4/8, that's the same as 1/2 x plus -11/8. Okay? And I'm going to look at that equation that I just came up with and compare it to the first one, or the other one that I had on here, which was y equals 2/3 x minus 5. And I want to look at these. So let's look at their slopes. This slope is 2/3, this slope is 1/2. They have different slopes. And if they have different slopes, these lines are going to cross. There's got to be some place where they can cross. Okay? You're going to have one solution. So anytime there's a different slope, it's a one solution equation. All right, last one down here, 1/3 x plus y equals 8. I gotta change this around. So I'm going to take 1/3 x away from both sides. I get y equals -1/3 x plus 8. So that's my first equation in slope-intercept form. And then the second one here was x plus 3y equals 12. I'm going to get my y by itself, so I take away the x from both sides. 3y equals -1x, because there's an invisible 1 right there, plus 12. Divide both sides by 3, and I get y equals -1/3 x plus 4. So let's look at these two equations here. Let's look at our slopes. Do we have the same slope? Yes, we do. So same slope. Do we have different y-intercepts? This one's at +8, this one's at +4. Yes. So same slopes, different y-intercepts. What does that mean? These lines are parallel. And they have no solution. So that is our new learning. We've been learning this for a while actually, but that is our new practice with this learning for today. Okay? So the new learning for today is that if our equations have the same slope, but different y-intercepts, then our lines are parallel and there is no solution to the system because parallel lines will never cross each other. Okay? And that's what we're going to practice right now. All right, for exercise 1, you are going to do this on your own. I want you to please take these 2 lines right here. They're already written in slope-intercept form. Graph them. And then off to the side, I want you to tell me how many solutions do they have and explain why. Okay, and I'll give you a couple minutes to do this because not too difficult here. All right, I'm going to go ahead and do this first equation in blue. So I start with my y-intercept. It's hitting this y-axis at +7, so right up here. And from there, I'm going to look at my slope. My slope is -5/4. So my rise is actually going to be going down because it's negative. So this is how it's going to go. Down 5, down 1, 2, 3, 4, 5, right 4. 1, 2, 3, 4. And I'll add one more point here. Down 1, 2, 3, 4, 5, right 4. 1, 2, 3, 4. So I've graphed my first line. I'm now going to graph my second line. I'll do it in green. All right, starting with my y-intercept, I start at +2 on my y-axis, so it's starting right here. And from there, my slope is again down 5/4. So down 1, 2, 3, 4, 5 over 1, 2, 3, 4. And I can work backwards. I can go up 5, 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is my second line right here. What do you notice? They are parallel. So these lines, there is no solution. And the reason? Parallel lines. And how do we know that they're parallel lines? Same slope. And the slope here was -5/4. Different y-intercepts. So we had 7 and 2. And that is our answer here for exercise number 1. Hopefully it makes sense to you. One thing I do want to point out is we didn't even have to graph this. If you would have looked at the slopes and said, oh, they're the same, and you would have looked at the y-intercepts and said, oh, they're different, you would have known these are parallel lines. Okay? All right, because we've done this already for the last couple of days, we're not doing a bunch of practice with it, so we're just going to close out the lesson. It says, one way to find a solution to a system of equations is to graph and to find their intersections. Wherever they intersect, that's your solution. So before graphing your lines, one thing you need to do is just make sure your lines are written in slope-intercept form so you can graph them with the slope and the y-intercept. But once they're written in that form, you can use that slope and y-intercept, the m and the b, to graph. Now the new part that we learned today is highlighted here. It says if your equations had the same slope but different y-intercepts, then your lines are parallel and there is no solution because they will never intersect. They were never going to cross. All right, we're going to move into the eggs ticket and then you'll work independently for the rest of the class period. All right, here is your exit ticket. I want you to sketch the graphs of the system, okay? So graph those 2 lines that they give you. And then I want you to tell me how many solutions do they have, okay? Or what is the solution, I guess I would say. Tell me the solution and explain. Explain. How do you know that? All right, and it's pretty much exactly what we just did in our exercise. So if you need help, go back and look at that. One thing I do want to point out before sending you off to do your work, this is y equals mx minus b. We need y equals mx plus b, so I'm just going to do keep, change, keep, change. So hopefully that helps you out a little bit. You should have already known that though, okay? When you finish with this, please work on Prodigy or Moby Max. And we are done with this lesson. Very quick and easy.